Inventory systems are a core mechanic of many video games. Unfortunately, inventory systems, especially in games with more complicated mechanics like durability or weapon customization, can quickly become a convoluted mess of spaghetti code swimming in jank sauce. For the purpose of this video, I will define an inventory system as a mechanic, or collection of mechanics, in a video game that revolve around moving items between containers in the game world, and in some cases, using them. There can be many instances of an item in the game world. For example, both the player's personal container and a container representing a chest in the game world can contain some number of gold coin items. The gold coins in both inventories share some properties, such as their weight and name. The gold coins in the player's inventory and the gold coins in the chest are said to be two stacks of the gold coin item type. This is my game Wrath of the Harvestmen, or more specifically, the post-jam remaster version, which is currently stuck in indie development project jumping hell. Despite the fact that this game is probably cursed to rot forever in my hard drive, it does provide a good example of how to make an inventory system that doesn't suck. In this video, I will go over the high-level details of how Wrath of the Harvestmen, or WAF's, inventory system works, and then discuss some implementation details in the Godot engine. The inventory system for Wrath, and many other games, has three major components: the items, item stacks, and item containers. This keeps the behavior for different types of items separate from the item stack specific data, as well as allowing for a wide variety of inventory types. The item class defines behavior for how items work. It is mostly just a container for data, like maximum stack size, item weight, or the item's display name. Additionally, in most cases, the base item class has a number of blank methods for how the item should act when used, transferred between inventories, or combined with another stack. To give an item type a specific kind of behavior, the base item class can then be extended. For example, the potion class, which is the child of the item class, can be given specific behavior in the onUse method to apply a status effect to the user. There should only be a single instance of the item class for every type of item in the game, and it's usually best practice to keep as much of an item's behavior data-driven as possible, in order to limit the amount of item types you need to code up. More on that later. The item stack class represents the actual items that the player will be interacting with in the game. An item stack instance will contain a reference to its corresponding item, as well as a way to store stack-specific information, such as the number of items in the given stack. Most of the methods in the item class should take an item stack as one of their parameters, so that this data can be modified and accessed. To return to our previous example, the onUse method of the potion item should take in the item stack that is actually being used, so that its item count can be depleted. It is usually best practice to store the majority of the data that would be specific to a certain item type in the dictionary. It wouldn't make sense for every item stack to have a durability stat, if less than a tenth of the items in your game even have durability, for instance. The item stack class should also have behaviors for being split and combined with other item stacks. The combining method in particular should return a remainder stack, in cases where it's possible to try and add more items to the stack than would be allowed. Last but not least is the item container. This class holds one or more item stacks, and is in charge of how they can be moved around and used. Inventories have a data structure to store their item stacks, and methods for things like automatically inserting item stacks or finding the first stack with a specific item type. Most of the behavior of this class is up to the particular design of the game. An inventory system like the one in Minecraft, where the player has a fixed number of slots and items can be placed anywhere and keep their position, would have an array of fixed length, where item stack objects are placed according to location in the inventory. Meanwhile, a Bethesda RPG-style inventory would just be an array of dynamic length. The sky's the limit with item organization. The Godot engine offers some powerful tools for creating item systems. Its resource system in particular makes it a breeze. The item class lends itself to the resource system in a very obvious way. Item types, such as potions, weapons, etc., can be defined as scripts, after which individual item types can be defined as resources in the editor, and automatically loaded at runtime. The item stack and item container classes can also benefit from the Godot resource class's abilities. Namely, the fact that they can be automatically serialized and deserialized by the engine for the purpose of saving the game. This convenience does open the door to a rather nasty bug, however. Oftentimes, when you are working with items, you will want to create duplicates of item stacks and inventories. However, the built-in duplicate method in the resource class has a major restriction. The parameters for this method allow you to either recursively duplicate all sub-resources, or none of them. Declining to duplicate sub-resources will cause the data dictionaries of the new item stack and the old one to be shared, which causes obvious problems. However, if all sub-resources are duplicated, then the item resource used by the item stack will also be duplicated for the new item stack, alongside opening the door to some rather nasty bugs. This wastes memory. This issue can be avoided by creating a custom duplicate method, which returns a new item stack with a duplicated data dictionary and a reference to the item class. A similar method can be used for duplicating item containers, but if you got this far, I assume you can figure that out yourself. Finally, I'd like to close out by going over how I tackled the related topics of item behavior and loot generation in Wrath of the Harvestmen. Godot's resource system also allows you to define a large amount of item behavior all in data. In Wrath, status effect items, medicine, food, etc., are all instances of the status item resource. However, the actual statuses they affect, and by how much, are defined by resources. This can be done in many ways, but in the game, I took the simple route of using the setParameter methods common to all Godot objects, which allows for arbitrary string keys to be used to set and retrieve object parameters. Similarly, the function of note items is controlled by resources. All items can have any number of event action resources, which have an empty method that takes in a dictionary containing the event context. Due to the incomplete nature of this game, I haven't been able to fully explore the utilities of this pattern. The only event actions I implemented were for the note system, i.e., removing the note item from the player inventory and setting a game flag once it was collected. Loot tables are also resources. The base loot table class has a blank generate method that returns a list of item stacks. This class is then extended to create more specific loot pool types. They can do things like choosing results from subtables with a weighted randomness, generating from subtables only if certain flags are set in the game's progress state, or returning item stacks with a random size. A single loot table is actually 10 to 20 nested resources that can be made as intricate as I want. So to recap, items are defined by creating instances of the item class, or its child classes, and storing them in some sort of centralized registry. Instances of the item stack class then reference these item types to define their behavior, and instances of the item container class, or classes, then define how those item stacks are stored. The Godot engine offers some powerful tools for creating inventory systems in the form of the resource system. The resource class also opens you up to some rather nasty bugs. If you don't know how object references work going into the topic, you certainly will going out.